In today's video, we're going to continue our investigation of solving one-step inequalities, but today we're going to focus on using the operations of multiplication and division in solving. So we should quickly review that if we have an operation of multiplication, then the inverse we will use naturally is division. And if we have an operation of division, then the inverse we will naturally use as multiplication. So that should be pretty self-explanatory because those are processes and ideas that we established way back in chapter 3 when it came to solving equations. Another quick review, as we've talked about over these last couple of days, when we solve an inequality that has less than or equal to or greater than or equal to, we will use a closed dot. And when we solve an inequality that's less than or greater than, we will plot with an open dot. And don't forget, we will always then plot or graph our array either to the right or the left based on the inequality. And always, always, always state your solution with the variable on the left side, because then our array will point in the same direction as our inequality symbol. So there isn't anything dramatic about how we solve these inequalities today using multiplication or division, because they're still one-step inequalities. But there is a really important rule that we need to remember. And we'll explain why this rule needs to be applied. But for the sake of the video today, we just want to make sure that when we multiply or divide by a negative number, when solving any inequality. So if any step in the process of solving the inequality requires us to multiply by a negative or divide by a negative, we need to reverse the direction of the inequality symbol. So if the inequality symbol starts out as saying greater than, and we divide by a negative to solve, it's going to have to flip around to say less than, for example. Okay? So we have it looks like we have 4 problems here that we'll quickly go through, and we'll be on the lookout for exercising this very important rule up above. Okay, so the first inequality, we see that we have multiplication. So we're naturally going to undo that multiplying by dividing by 3 on both sides. The 3's will naturally cancel, and I will get x is greater than or equal to 4. Notice we divided by a positive, so that doesn't fit the rule that we have up here. So we don't have to worry about any flipping of the inequality symbol at this point. But let's not forget that solving is only half the answer. The other half of the answer is that we have to draw our number line, put 0 as just a point of reference, mark your 4 as the value that shows up in your solution, and given the inequality symbol, make sure you mark a closed dot. And because the variable is on the correct side, meaning the left-hand side, we can rely upon the inequality symbol to tell us to draw the graph to the right. And then we're done. So let's move on to the next problem. In the next problem, there's a negative sign right here. So we want to be careful in terms of how we treat that. That basically says the equivalent of n over negative 6 is greater than 8. Or another way of writing that is n divided by negative 6 is greater than 8. Okay, but what we can see right away is we're dividing by a negative, so we're going to have to undo that by multiplying by a negative. So we're going to multiply by negative 6 on both sides. I could even do it the way I have it written over here, multiply by negative 6 on both sides. What that causes to happen, of course, is that the negative 6's cancel, or in the case of writing it horizontally, the negative 6's cancel, and I get n equals, I'm sorry, not n equals, but no longer, it won't say n is greater than, because we just flipped. So here's the type of problem where we have to use our rule. Instead of saying n is greater than, we're going to flip the inequality symbol. and say n is less than negative 48. And that would hold true even if I did the problem this way, because I am multiplying by a negative. Because I'm multiplying by a negative, I need to flip the symbol, flip the inequality symbol. So that's what we did. So all we're left to have to do from here is graph. I didn't give myself a lot of room for graphing, so I'll try to squeeze it in with an open circle. And because our inequality symbol flipped around, we're going to go to the left with our final answer. Okay. So let's take a look and see if either of these two remaining problems requires us to multiply or divide by a negative before we even get into the problems. Okay. So this next problem, it looks like I'm dividing by positive 3. So to undo that, I'm going to have to multiply by positive 3. So is that requiring me to flip the symbol? Definitely not, because I'm multiplying not by a negative, I'm multiplying by a positive. So we don't have anything to worry about there. In our next problem, we have to undo the fact that we're already multiplying. And what are we multiplying by? We're multiplying by negative 12. So we're going to have to divide by negative 12. So once again, we can see here's that alert going on. Divide by a negative, switch the symbol. So that's one that we're going to have to switch the inequality symbol on. Now what you will notice is both of these are also backwards. So we're going to have to turn these answers around. That's different than just flipping the inequality symbol around. So what we'll do is just solve these and then turn there and do what we need to with the inequality symbol, and then worry about turning the entire answer around separate to that. So let's take this one through. So I know I'm going to have to multiply negative 51 times 3. That gives me 3 and 15. That gives me negative 153, if I read from left to right, is greater than, than n. That's a backwards answer. So we're going to turn that around. We're going to turn that into n, reading from the variable, is less than negative 153. Notice I didn't just turn the inequality symbol around. I turned the entire solution around and maintained the truth of that answer. So this is really important to understand. This is not that really important rule from above in action, because this is just a matter of getting the variable on the correct side, which means a complete 180-degree turn. Let's solve the last one, and then we'll worry about going back and graphing. So here, I divide by negative 12. I divide by negative 12. So what's negative 48 divided by negative 12? That's 4. Is greater than or equal to m. Now again, this answer is backwards. Now, oops, you can see I made a mistake already because I needed to flip the inequality symbol. So the fact that I divided by a negative required me to change it from saying 4 is greater than or equal to 4 is less than or equal to. That's my rule at play, flipping the inequality symbol. Separate from that is going to be the need to turn this entire solution around so that we can see m on the left-hand side. So to maintain the truth of this, reading from m, we would say m is greater than or equal to 4. So there were really two needs to turn things around. There was turn the symbol or flip the symbol, and then there was flip the answer. And they were for two very different reasons. Flipping the symbol was because we divided by a negative. Flipping the answer was because we had a backwards answer. So if we quickly go back, we can draw our number line. Open dot to the left, which works with our solution, and we can draw our number line. Close dot to the right, which matches. So that is everything we need to be concerned with right there, with multiplying and dividing as our way of solving. Remember that really important rule. When you multiply or divide by a negative, reverse the direction of the inequality symbol.